Nora Harhen will open the stage, please.
Great, thank you. So today I'm going to be talking about some work that I've done in collaboration with my PhD advisor, Erin Bornstein, and my postdoc advisor, Kate Hartley. So I'm a developmental psychologist. When we think of childhood and adolescence, it's often characterized as these special periods during which we can eagerly explore the world and fearlessly take risks unencumbered by very many responsibilities. And then in adulthood, we can take what we learned during these earlier periods and use that information to flexibly and efficiently achieve our current goals. A growing body of work in developmental psych has tried to figure out what mechanisms are supporting this developmental shift from exploration to exploitation. Much of this work has focused in on how differences in exploration emerge from differences in motivations. So children will prioritize obtaining information over obtaining immediate rewards. They're also more tolerant of uncertainty, and they just generally act more stochastically. And these differences are often formally expressed in terms of algorithms. So children will act according to an epsilon greedy choice rule, whereas adults will be more softmaxy. And with this project, what we wanted to ask was, could there be another potential source of difference? A difference in how the environment's internally represented. So could developmental differences in representing the structure of environments also contribute to differences in exploration? So to get at this, we had 252 8 to 25-year-olds complete a patch foraging task that we've used in previous studies with adults to measure individual differences in structure inference. So in this task, you're a space explorer who's visiting these different planets to mine for space gems. The gem mines on these planets will deplete the more you dig from them. So you have to decide when's the right time to leave a planet, incurring a time cost to travel to a new planet with a replenished mine. So while all planets depleted the more you mine from them, they did so at varying rates. So planets could belong to one of three types. Each of these types was associated with its own unique distribution over depletion rates. So importantly, these differences are in richness are completely latent. The planets are visually identical to one another. Planet richness also tended to correlate in time, but occasionally when a participant decided to leave a planet, they would switch or transition to a planet of a different type. So we built a model for how foragers could learn and leverage the structure of their environment. And it's comprised of two mechanisms. One of them is this Bayesian structure learning component. Which treats the learning problem as a cluster inference problem. So for those familiar, this is a Chinese restaurant process. So within our task, the learning problem becomes figuring out how many planet types there are and assigning individual planets to these types. And doing this on the basis of how quickly these planets deplete. So when we fit the model to individual participants' behavior, we allow for individual variation in terms of the structural priors over environmental complexity. So this is captured by the parameter alpha. The higher alpha is, the more clusters you'll infer. There's also a second component. I'm not going to be talking about that. Please come to the poster if you're interested. So now quickly for participant data, on the y-axis, I'll be plotting the planet residence time, or the number of times the participant dug on the planet, and I am subtracting out the optimal number of digs that's given by the marginal value theorem. So, and then on the x-axis, I'll be separating by planet richness. We're going to define exploration and exploitation in reference to marginal value theorem. So 0 would be considered optimal, anything above it would be exploitation, anything below exploration. Our model makes predictions regarding how different representations will produce different patterns of exploration. And I'll point out that these differences are most notable on the rich planets. When you look at participants' data, you can see that younger participants act in greater accordance with a simpler single planet type representation, whereas older participants act as if they're using this more complex representation. And then adolescents are sort of falling in between there. So if we return to the question we originally posed, it does seem, yes, that there are these developmental differences in inferring and representing the structure of the environment, and these seem to be shaping exploration. So to just wrap up, please come to the poster if you're interested about the other part of our model and the data that supports it, and also come to hear about the model fitting results. Thank you.